Okay, it's Keith from Sunsynk. I have done many presentations around South Africa. Unfortunately, due to the COVID and everything else. Normally I'd be in Hong Kong, but I'm actually in the UK at the moment. So this is the UK office. So today I was just going to do a very basic presentation about our inverter, and to give a very basic understanding, because some people don't quite get the understanding on certain things and don't follow some of the issues and how it functions. So I'm just going to go through it's a basic introduction and to try to give you an understanding what it's all about. You can see there's a couple of inverters behind me. So we do from 3.6 to 12 now. We do 12 kilowatt. So let me start off and I can explain a little bit more what's the difference and why our inverter is different to other inverters. So I'll just change my video across. So this is a pretty standard, focus it. So this is traditionally what everybody's familiar with when you're looking at an inverter. So you've got a battery, an off-grid inverter, a changeover switch. Many of the regulations still in South Africa, they still use changeover switches because they don't realize that the newer modern AC coupled inverters don't need changeover. But some of them have these sort of changeover where you're running off the AC and you flick over and you're running off an inverter. And this type of inverter is what's been around for a long, long time. So looking at our inverter and looking at some of the more modern inverters, and I mentioned that because the first drawing I showed you, the first one, I just go one back, many of inverters still sold in South Africa, and a lot of the cheaper ones work in this way. You have an inverter, you have a relay. When it's running off grid, clonk, the relay goes through the inverter. There are lots of problems by doing it this way. And the problem is you're governed by the size of the inverter. If your house needs 5 kilowatt, 10 kilowatt, you have to have a 10 kilowatt inverter. Whereas the way we do it, it doesn't quite matter. So this is the way that we do it. And this is basically known as AC coupled, where the inverter connects to the AC line, pretty much like a grid tied or a microinverter. But the difference is we add a CT coil. CT coil is very, very important. The CT coil is the heart of the inverter. Without the CT coil, the thing cannot function. And many people actually fit inverters and they don't fit CT coils. They don't really understand why it doesn't function very well. But the CT coil, and I'll explain more about why the CT coil is important. But basically, ours is a bi-directional inverter. That means the inverter itself can charge and discharge. It's one device. It doesn't have a separate charging circuit, and it doesn't. Just let me admit somebody else joining us. 2 more people joining us. It doesn't have a separate charging circuit. It has the same inverter. So basically, if I look at certain inverters, and I'll use, for example, a lot of the expert inverter, they will have a charger inside the inverter and they'll have an inverter. Ours is the same device. The whole inverter reverses. That means it can't charge the battery and discharge at the same time. It can only do one of the other thing. The MPPT, the maximum peak power transfer devices, which is a DC to DC converter, is separate. So it can charge from the solar and discharge through the inverter, but you can't charge off a generator at the same time as discharging the inverter. It will only do one other thing. And so when the inverter is running, and for example, if it's running off the AC and it switches over onto a UPS mode, an islanding mode, the whole inverter, the whole machine reverses. So the whole machine goes into a complete reverse, and you have a very slight delay because you've got to expect that the thing is functioning one direction and suddenly the whole thing goes backwards. And that's how it functions. And it's very important to remember that. When you're looking at, and I just show you on here, when I'm just going to claim these drawings. So this is the board off an 8 kilowatt, but they're all pretty much the same thing. And you have a grid connection, you have a generator connection, and your load connection. The grid is both an input and an output. It's the same connection. If you're working off grid and you're not using a battery, you're using it as an off-grid inverter, you only connect to the grid connection. And this is both in and out. Some people think, oh, that's in and that's out. It's not. That's a UPS. That's an uninterruptible power supply output. Maybe we should word it differently, but it's a UPS. This is your input. And also it's an output. And what often we need to always consider, and I'll come on to this, your connection on the grid side is your essential loads, sorry, non-essential loads, and the load side is your essential loads. So if you have a power failure, power outage, load shedding, whatever, then the load side will continue to operate, but the grid side, you will lose it. But you also have to consider power balancing, because what you don't want to do is have any big, heavy air conditioners and stuff connected here, because you get a huge inrush current. And often when you switch an air conditioner off and you switch it back on again, there is a massive inrush current. And that inrush current can cause an overload. It's not a fault on the product. It's just purely because of an old air conditioner. So always remember that. So maybe if you've got big old, connect them on the grid. It will still run from the solar. When the sun is shining and you've got grid there, it will run like a normal on-grid system. No problem. If you lose your power and you have load shedding, then your load side will continue to operate. So your lighting circuit, maybe security lighting, maybe some sockets, maybe some fans or whatever, but you don't want to connect too much. You want to keep it because that's going to soak up your batteries, and you just need to balance it. So always consider the two sides of it. So I'll come back to that in a second. One of the things I was trying to emphasize before is the inverter, which is the bi-directional inverter. So here is your grid connection here, and this is your non-essential load connected here. And basically the CT coil, because a lot of people forget about the CT coil and think, oh, it's not important. It is the most important part of the inverter. It's a current, CT stands for current transformer. And basically this is the thing that controls it. If you don't have a CT coil, then it will just go back and it will export to the grid, and it'll have uncontrollable export. You can't control it. So the CT coil, and also remember the direction of the CT coil. And the CT coil, and I'm going on a little bit about it because I always have issues. This is the CT coil. It mounts here so on the main fuse coming in, it must be on the main fuse. Ensure the direction is an arrow on the CT coil, and the arrow faces towards the inverter. And you just see a small arrow, and that goes towards the inverter. This is so important, and I keep going on about it. So maybe I may come back to it again. So going forward, just literally mounting the inverter.
That's my thing. My thing is not the test.
Sorry.
Yeah, the fourth. We got to do that. Well, the end of this month. End of the month.
Okay, sorry. I'll carry on. The mounting of the inverter is important because there's ventilations at the side of the inverter. So if you're going into parallel, try to keep them apart, especially if you're in a hot environment. So it's quite important to keep the distance on the inverter. We always recommend a meter, but that's quite important. So go forward. You've mounted your inverter, you've connected everything up, and this is what makes our system unique. We have a really nice, I think we have one of the best operating systems. We've looked at changing it, and I'm open for suggestions, but I don't really want to change it too much. And we try to keep this very simple. And one of the things, when we first started to develop the inverters, our first trials were on boats. The problem with boats is there's no, and these were liveaboard boats. These were big boats, so 3,000, 4,000, 5,000 square meters, huge boats. And there's no power. They've got no power, and the only power they've got is either a generator, which they have to run, or they've got the solar panels on the thing. But there's no AC. They're in the middle of the harbour, and they can't run a cable and plug it in. So it was very important to always consider what went in and what come out, and especially if you're on off-grid systems. And this is nice because you can see very clearly how much you've produced, how much is going out each day. And if you've got more coming out than going in, you're going to get a problem. And the users get that. They totally can see that. Here, very clear, your state of charge. So this bar chart here can very clearly show this is an accumulative day figure. So all these are generally, apart from the state of charge, these are all accumulative. So here you see your solar, what you've generated in the day. You see a state of charge with your battery level. If you're running a generator, we show how long the generators run for. And of course, we've got buy and export power on accumulative. The dials at the side are real time. So as things ramp up, if you got the sun is shining, it's great. You'll see the dials all shoot up and they'll come right up. Customers love it, absolutely love it. And it's so easy to see, and you can see straight away exactly what's going on. But the most important thing is I always try to explain to customers, they say, oh, my battery's gone flat. Well, how much power you used? If you've used more than you generate, of course it's going to go flat. But so it's important, and people get that. They totally get that. We also added here, because people we got asked by some of the installers about putting the name on, and you can put your company name on, which makes it quite nice. Or if you guys are brave enough, put your phone number. And I know some of the calls I get, and some of the customers are very, very interested in lots of things and want to know every ins and outs. And I apologize, because I get so many text messages and WhatsApps and emails. Sometimes I'm a bit slow to respond. We're actually getting some extra staff, and we'll improve on that. So I apologize if you send a message to me and you don't always get a reply. There's a couple of other things going on here. You see, obviously, how the inverter is on. And this also, when you're doing an update, this icon changes when there's an update going on. You see here, this cog is to access the programming. It's a simple program. This also changes color when the generator is running. So if you're running a generator, this will change color. So you've got lots of things going on. And we also add helpline pages. They're very basic. It's more for sort of end user, and they can click it and they want to see what it's about, and they can do, and it gives a simple explanation. But this is the thing that accesses it. The other thing is, by clicking the various dials, you can access different things. Now, if you actually click on the bar chart itself, I don't know if you've seen these, you'll get this flow chart, the system flow chart. I love this, because this shows you exactly what is going on. And you can see you've got the MPPTs. You'll see the power coming through the MPPTs, each MPPT, the accumulation of the power. And then you can choose. You can decide, do you want to use that power to charge the battery first, or you want to use the power first? That's an important point, because if your battery is low, if you decide the most important thing is to have a full battery, then you will direct that power to the battery, and I'll show you how it's done. Or you can use it, and any surplus will go to the battery. It's two different modes of operation. So charge battery first. If you're charging the battery first, and you may have lots of power coming off the sun, and you're charging the battery first, you may well end up drawing power from the grid. So your grid could be supplying. You say, well, it's sunny. It's really sunshine. I'm generating 5,000 watts, but I'm still drawing 2,000 off the grid. Why? Because you probably directed the energy to charge the battery first. And so a lot of people do, because they want the battery for load shedding as an emergency. So they put the solar first, go to the battery, and secondly, go to the load. And if that's the case, you will draw power off the grid, because the batteries, or you can have the power go into the load first and the surplus power go into the battery. And you can choose what you want to do with it. You see here your three outputs, which is your grid connection, UPS, which is the load, and the auxiliary, which is the generator. It's worded slightly different here. So your grid, UPS, auxiliary. So auxiliary we call as a generator, but it's actually an auxiliary, and it can do lots and lots of things. The UPS is a UPS load, uninterruptible power supply, which we call the load. So this is your essential loads, UPS, uninterruptible power supply, stuff you don't want to fail. And here is your grid. So by actually clicking onto the one of the dial, you will actually see it. You get this matrix, which is just another form of the first page. And in fact, when we're going over to our new 3-phase, and I explain that in another thing, there's a lot more information here. But on this page, obviously giving you the basic information of the battery, giving you what's going on at the inverter, the power. It's telling you the load. It's got the grid power, and here we're also actually showing you the CT. So here's the CT. This is the external CT that you pick up. There is CT coils inside the inverter. Now, just before I go on that, We have a few people mention questions. They often say, oh, they look at the wiring on here and they look at our internal wiring. And some people say, oh, but we see negative, marked negative or positive or whatever on the internal wiring. That doesn't matter. It doesn't matter. Always use the connections that's marked on here. There are some reasons why we change it around on here. And the reason why they're actually changed here is because some people link the neutrals together, have a common neutral buzz. And we had an issue in the past because we put our internal CT coil on the neutral. And when they were linking out the neutral, gave a problem because they actually bypassed our internal CT coil. So we swapped some of the wires around. So it doesn't matter. That's just something that happens. So I point that out because it's a general comment. I go on and on about CT coil. One of the things is here says CT coil. If this becomes a negative, if this is a negative when it clearly shouldn't be a negative, then you're actually the CT coil is backwards. Again, is a common problem. People often do have it backwards. And we always pick up. Going back onto the main front page here. So if I press this button here, this will take me to this page. This is the navigation page. I'm showing it on drawings rather than showing it on the main unit because it's just easier for me to explain it that way. But this is the navigation page. First one is your basic settings. I'm not going to go through to that. That's basically, if you want to turn the beeper on and off, the beeper's annoying you. Some people, the beeper defaults on. You want to set your name on the unit. You go through basic settings. So it's a fairly straightforward thing on the basic settings. Battery, I'll come to the battery in a minute because the battery is very important on the battery settings. Grid. You'll see lots of complicated things on the grid settings. Most of it ignore. There are certain regulations, for example, in Australia, and they have some rules and whatever set by the power company, which is absolutely nothing to do with South Africa. And people say, well, what's this? What's this? What's this? I'm not even going to go through it because it's fairly complicated. All you need to look on the grid is your high voltage, your low voltage. This should be fairly tight unless you're sort of at the end of a line, or some people using swirl line. Where if you're on a swirl line, you might get massive changes in voltage, especially I know like sort of Namibia, they're on swirl line, which is a single wire with a neutral which is returned by the ground. But generally the main should be stable-ish. If you get a grid voltage which goes very high, really high, that's often due to what they call a lost neutral. And with the three phases creating a neutral, that's dangerous. And the inverter should cut off. And if it cuts off due to a very high voltage, then there's a problem. You need to investigate it because that's dangerous. And if I've seen it, and I've seen it in the UK once. I've seen it in South Africa about 20 times. Where people have stolen a neutral cable because they felt it's the safest wire to steal. And then suddenly the grid creates the three phase creates its own neutral, but the neutral can reference off another phase, and therefore the voltage on the phase that you're picking up can rise massively or decrease. So it's quite dangerous. Advanced settings, I will explain another thing. Advanced settings, I'm not going to go through now. Auxiliary load, this is where we're using the auxiliary or the gen port. It can be working a generator. It can be working microinverter. And again, this is more of advanced, and I'll go through this another thing. Fault codes. I just mentioned one thing about fault codes. Fault codes is a diagnostic tool. It doesn't mean the inverter is faulty.
Ek het vir jou die tokens gestuur vir daai drie prepaid meters, omdat as hulle in is, dan moet jy
sorry, can somebody said it doesn't mean that the inverter is faulty. The fault codes is a system diagnostic tool. It's a tool. It means there's something wrong with the installation. And I try always to explain about fault codes. Come back on my video. people don't get it with fault codes. You think, oh, it's got a fault, whatever, fault 29, or a paralleling fault or an overload fault. It means there is a system problem. It doesn't mean the inverter is monitoring the whole system. It's monitoring your solar panels. It's checking you've got no air fault on the solar panels. It's checking your voltages aren't over voltage. It's checking your current is not high. It's checking everything. There's lots of things going on in the inverter because the inverter has to shut down. If anything goes wrong anywhere, the inverter must shut down for safety. It's pretty much like an RCD, a residual current device. If you have a slightest fault, the residual current device will shut down. The inverter is the same thing. It's monitoring the system, and the fault codes are a diagnostic tool telling you why it was shut down. And the reason is nearly always, 99% of the time, it is to do with an external event. Often it could be a solar panel earth problem, the live going to the earth. It could be it could be a voltage over voltage, under voltage. Under voltage is often very common. Frequency of the AC it can be that tends to happen when you actually using generators, because generators can often cause that. So let me sort of carry on the sort of this other side. So this is the part that people confuse, the controller. So if I access from here, is system mode. It's from here, and on here you'll see this is what always confuses people. Now I'll explain a little bit. We're going to make a change to this. So there is a new version of the software. I think it's 416, which will be released very soon, and there is a very slight change to it. So at the moment, which will be better. The moment, this is the thing that controls the system, what's going on. Okay, so I'll leave this part of it for now, and this is often confuses people. Here, click it if you're going to use the timer. If you're not going to use this timer, this is a timer, this is a real timer. Here is your priority to load. This tells you what you want to do with the solar. If you click here, it will put the solar to the load first and charge the battery secondary. If you don't click it, it will do the other way around. So if you unclick it, the power will go to the battery. So you might have a bright sunshine day and your client will ring up and say, oh, but I've got bright sun and I'm using mains. Why? My meter's going round. Because of this. You have to choose what you want to do with the power. Now, we've just changed some of the wording on here because it causes a little bit of confusion where we say zero export solar. Okay, so basically this now, tick this if you want to use this feature. So this is zero export. So if you click here means you can then choose, do you want to you can export solar or you can limit to load. So basically this is two different things going on here. And you would use this. So this, you click this on one of these. You can't click both of these. It's one or the other. You choose. And I can explain a little bit more about when I come a bit more to that in a second. Zero export power. This actually is for prepaid meters, and it's specifically designed for South Africa. So often on a prepaid meter, an electric meter, you've got the power coming into the meter. The problem with the prepaid meter is if you try to go back export power through a prepaid meter, it will lock out, it will shut down, it will trip. And that's what it's supposed to do, because you can't export off a prepaid meter, because maybe people try to make them go backwards, I don't know, but you can't export. So what we have to do is allow a small amount of power, because when you've got a single wire, there will be a voltage level on the wire, and the prepaid meter may see a power, and because of the speed or whatever, there's a very slight chance of a small amount of current passing in reverse. So to prevent that, we allow the power to pass one way. So typically on this setting, we would typically on this setting, on the zero export, we might put 20 watts. So typically it would be 20 watts. If you're on and I'll show you on here, if you're on a and I put 100, some meters are very sensitive. So we put 100 watts here. They're very sensitive, but that means that you want to keep that as low as possible. 100 watts is a bit high, maybe 50 watts, depending on the meter. So depending on how you set this, but this is quite important, but this is for prepaid meters only. And this allows a certain amount of power to flow. So this is wasted electricity, in other words. People don't like it, so they want to keep this to a minimum. My coffee. Right, this next one, maximum cell power. This is actually the global power of the inverter. So this is the inverter's global power. It's the maximum power the inverter can run. It's very important. It's not your cell power, it's the whole inverter. Often we see these set to 0. If it's set to 0, the inverter won't work. So it's very important. Sorry. So carrying on this, the timer here. Use timer. This is real time. So basically you set the time, and this is when it will activate. If you don't put any tick in here, it will switch off on that time. So on here at 24 at midnight, and the power is 2000 watts, and it will tell I want the generator, the grid, sorry, to charge my battery to 100%. That's just an example. So at midnight, I want it to charge to 100%, and I can click here, and it will take it to 100%. At 6 o'clock, okay, I want to stop it. I want to allow to 20%. So this is a stop signal. So this means stop, because there's no tick on here or here. We are going to add it and put a tick on it, because it does cause some confusion. So with no tick, it means stop. With a tick, it means start. So this always does cause a problem. It does take a bit of getting used to the controller, and that was one of the reasons we have made the change. So on the version 4.16, you will see it's a much easier work. But when you set anything to charge or discharge, or your battery level, you must also make sure you've done the other settings with it. So without the other settings, would give a problem. And I'm going to just skip a couple of the pages too, because they're not really relevant. So going forward, move my camera to the other. Sorry. Okay, back. So controller is absolutely the heart of it. You don't need to use the controller, because the unit will naturally work as a UPS. So it will work as a UPS if you don't even use the controller. But one of the things you must do is you must set your battery setup. And I'm going to show you onto the battery setup now, because that's important. If you're going to charge, you discharge, you must make sure the battery can do it and the battery settings are correct. So on the battery setup page here, and this is the, of course, you've got your battery type. I'm not going to go into that, because I don't, otherwise I'll take forever if I'm going through every point. But your battery type is you choose whether you're running as an AGM battery or a lithium battery. When you're running with a lithium battery, and we'll just focus on the lithium battery, you must make sure you've got communications. Absolutely must make sure you've got communications. This is on here. This is check your communications. You put your cables in. So you'll put your connection here to your battery, whether it's a CAN bus or it's an RJ45 or whatever. You put your connection on, it will go into the battery. You have to follow the battery specification, and you must make sure you have communication. If you haven't got communication, you will see a screen like that. When you click on that particular button, when you click on here, you'll get a screen like that. It means it's not communicating. If the battery is not communicating, all your state of charge and all your figures will be completely skew with. It won't give you correct figures. And if the state of charge is not giving you correct figures, then the controller can't do a correct job and everything won't work. It will be a complete mess. You must make sure that you get something like this. You will see a very clear thing coming from, this information is coming from the BMS, the battery management system. And if you don't get a very clear message like this, then you've got a problem. And this happens a lot. A lot of people don't realize the importance of the communication. Now, if you're going onto, I'll move back, if you're going back onto your battery here and you haven't got communication, or the battery can't communicate, and we've just got a list of all the batteries that we recommend, and there's lots of batteries we recommend, but it doesn't mean that all lithium, we don't mean that all lithium batteries can communicate with our inverter. So because the inverter is one half of the battery management system. So the battery management system is saying to the inverter, look, this is my state of charges. The reason why it can do it is because when you want to measure a battery's condition, people use voltages. And the battery management system can take the voltages. Now, when it's away, when the battery is further away from the inverter, then you've got the cables and you've got losses in the cable. And because of the cable losses, it's very, very difficult to actually know what's going on. And so these losses, you can't get a correct figure. And this is part of the problems that you'll have if you're using AGM, lead acid batteries. Now, I know most people are tended to go to lithium batteries because longevity and lots of benefits. There are people still using AGM. And also, if you have a lithium battery that's not communicating properly, and you've got to go to your AGM, then you must set this up as an AGM battery, and you need to know these voltages. You wouldn't, if it's a lithium battery, you wouldn't use the equalization. The equalization is for lead acid only. If you use equalization, it takes a higher voltage onto the battery. If it is a lithium battery and you use equalization, you will damage it. Never, ever, ever use equalization on a lithium battery. So these should be set 0, 0. These voltages here, if you're using a lithium battery without communication, then you have to know these voltages. Now, there are lots of batteries turning up. I'm seeing lots of sorts of companies and lots of these little battery manufacturers turning up, and their communications are not very good, or they're not compatible with a lot of inverters. And it's important because, batteries are really, really important to communicate. But if the battery is not communicating, it doesn't matter. As long as those settings are correct, and you must get that out of the battery. If you have a wrong setting and you try to overcharge the battery, then that's where you get a fire. You got a fire risk. So you need to make sure they're correct. Otherwise, the thing will go on fire. So this is a very important aspect. The other thing, what I was showing on here, is the battery, and I'll go back onto it here because this is important. This also denotes you're setting your battery charge, and you also have your battery discharge. So on here, I'm showing my charge. On another page, it will show the discharge on the type of battery. Charge and discharge of your battery is very, very important. The maximum charge and the maximum discharge. I should have had another slide actually showing on the battery type, but I haven't. I'm sorry, I didn't prepare it today. So the battery discharge is what they call the C rating of a battery. The C rating is and you need to calculate. So if you have a C rating of the battery, if the battery is a 100 ampere hour battery, so 100 ampere hour, 48 volt would be a 4.8 kilowatt hour battery, but this 100 ampere hour would relate to the C rating. So if the C rating is 0.5, that means you can draw 50 amps charge, discharge. You can't go more than that. Generally, most of the lithium batteries are 0.5. There are a few on the market claiming they're 1. Just be cautious, but there are a few which are 1. Some of them even bigger. But when you go bigger, your cable thicknesses have to go up, and that BMS has got to be handle it. And if people say we've got a C rating of 1, double check it. Don't just risk it, because otherwise you'll vaporize the battery. So that's important. So that's your charge and discharge. So if you've got a 50 amp discharge on a battery, that means you can only draw 50 amps off that battery. And if you've got 50 amp, 48 watt, you're only going to be able to draw 2.4 kilowatt. So if you've got an 8 kilowatt inverter and the battery set at 50, if you try to draw more than 2.4 kilowatt, it will shut down. It will overcurrent fault because the battery setting is limiting it. So if you up the battery, you'll damage the battery. So it's very important. If you're using the AGM battery, the C rating of AGM is much lower. They claim some stupid C ratings, but really, from my experience, 0.1, 0.15, you need to keep it very low. So if you're using the AGM batteries, you have huge banks of it, so it doesn't matter so much, but they are very low. So you can't just get 200 ampere hour AGMs because you're going to be able to charge and discharge it very little. So you've got to really, you'll just damage it. The battery won't last very long. So you've got to really watch. The C rating is important, but typically work on 0.5. So that's the maximum charge and discharge. So when you're matching your inverter, so think about the battery. If you're going to match your inverter, somebody wants an 8 kilowatt system, and you're going to use 0.5, you're going to think, well done, I need 3 batteries or 4 batteries, because 1 battery or 2 batteries ain't going to give me enough. 2 batteries are going to give me 5 kilowatt. I'm going to try and draw 8.8 kilowatt of 2 batteries. You're not. You'll damage it, and the thing will shut down. The BMS of the battery will shut it down, and you're going to get an overcurrent fault. And then you're going to contact our customer service. Oh, the inverter's faulty. It's got an overcurrent fault. It hasn't. It's just doing its job. The battery say, the BMS of the battery saying to the inverter, whoa, you're taking too much power from me. Shut down. The inverter will show a fault. And if you're in parallel, you might get an F29. The parallel system will drop down. Because the first thing is, if you get a fault, the first thing that will always happen is the paralleling system will drop down. So the paralleling will shut down and the inverter will shut down. That's the order of what happens. So you'll see an F20, you'll have a communication fault shown because the paralleling shut down. And then you will get a fault, an overload fault. And just check your C rating of your battery and make sure. And if your battery is not communicating, then you can get all sorts of things. I often say, if you haven't got a battery that's going to communicate correctly, use voltages. Don't use percentages, because SOC, state of charge, is extremely difficult to calculate off a voltage. And the problem is, when you load the circuit, the voltage drops. When it's offload, the voltage comes up. So how can you measure it? The BMS of a battery is a bit smarter. So when it's discharging, it knows it's discharging, and it will recalculate its SOC. When it's charging, it knows it's charging, and it will recalculate it, and it will send that information. And that's what makes a very good BMS, battery management system. It can do these calculations. When it's discharging mode, when it's charging mode, it can calculate it. It can do these fairly complicated calculations, and it can give you accurate information. If you can't do those calculations, or there is an issue with the calculations, because you've got no communication, then I will always say use voltage. And then you know when, if you're on a discharge, we often, in our manual, we show on an AGM battery the charge voltage and the discharge voltage, and the difference. You've got a differential, because you have to have a potential difference. To charge a battery, you need more than the battery voltage. To discharge, it will go under it. So there's always a potential difference. We can show, and people, you say, look, if you want the thing to do if you want to do something at a certain point, then when the voltage reaches this voltage, it can do it. And that makes a little bit more sense. And also, when you're using voltages on the front screen, the bar chart will change from state of charge. It will become a voltage measurement, and everything, all the settings become voltages. And you have to educate your customer a little bit. Use voltages if you've got no communication. Don't try and using SOC, state of charge, if you've got no communication. If you've got good communication and the BMS is working well, and I showed you on the page, click on that, check it. First thing you must do when you install the system, check your communication is working on the battery. If that's working, you're good. You're really good. If that's not working, you're in trouble. So it's important to do the basics. When you install, check your communication, check your battery currents before you do anything. And at least you're safe. Now, I'm going to go to one other thing is relating to which always causes a problem. Solar panels. Right. On our inverter, we have two, generally some of those one, but most of them have 2 MPPTs. MPPT, I try to explain this and explain it. The most important thing about it is voltage. So voltage again. It doesn't matter. People say, well, I'm going to put so many watt array. Fine, you can do whatever watt. You can have a 1 billion watts array, but your voltage mustn't exceed. The inverter will pull what it needs. That's what the MPP does. The MPPT does is it actually pulls what it needs. As the voltage goes higher, the current from the solar panel will be reduced, because if you actually look at you're looking at your wattage. So obviously your voltage multiplied by your current is your wattage. If you've got an MPPT in the unit, which is a 5 kilowatt MPPT, so your voltage times your current will be your wattage. You're not going to create more wattage. You're not going to make the MPPT bigger by increasing the voltage and say, oh, my current's not increasing. It won't, it'll drop. So as the voltage increases, the current will drop. It has to, because otherwise the DC to DC converter in the device will overheat. It can't do it. It control the wattage. Voltage is king. We always say 450 volts. The truth is the MPPT can withstand about 520 volts. Above that, it will shut down to protect itself. If you go close to that, you don't really want to go close because it's dangerous and it can cause damage. And in any case, 500 volt or 450 volts is a lot of power. We're in DC land, and as you guys know, DC land is not AC thing. And if you get an arc and you create a sort of plasma arc, and a plasma arc can jump sort of that gap, you can create a plasma arc that gap of about 450 volts. On AC, you're like, well, tiny, a couple of mil, if that. But 450 volts, DC land, you create that. And that's why it's so important that you've got very good quality combiners, very good quality connectors. And one of the things the inverter will do, it checks that any bad connection, if you've got a bad connection on your solar panel, it will shut that inverter down. Safety. Because if you've got a bad connection and you get an arc creating, you get a plasma arc, then it will burn. It will go on fire. It's a massive fire risk. So the inverter is protecting everything. It's very, very important that it's protecting everything. So voltage is important. You can calculate your size of your solar array and however you operate your solar array, but please always just look at your voltage before you connect it. You look at your panels, your voltage side, your VOC, voltage open circuit. And some people say, well, the current is dropping and my voltage goes up. Of course it's going to drop. It's the wattage. It's going to drop. And that's what it does. It's a tracking device. It tries to make the most of the panels. Really, you don't want to oversize the panels too much, the MPPT, because you're just wasting energy. You're just wasting the panels. It may give you a bit longer sun day if you wanted to, the sun hours, because obviously I think in South Africa you've got a ratings figure of 5. UK, we've got a ratings figure of 1. There's no sunshine. Sometimes it surprises me, but basically the ratings figures, it doesn't exist. So it's a different thing, and I will talk about for our UK customers is a different thing altogether. So I've tried to cover the basic understanding of what the inverter is. It's a bi-directional inverter. I've tried to explain about the importance of the CT coil. I've tried to explain about the importance of the battery, that it's communicating and the settings are correct. And I'm talking about the panels, making sure your voltage, your VOC is not over voltage. If you follow all of those basic rules on your commissioning, it will work. It will work fine. Often faults, as I say, are caused by maybe a faulty solar panel, a bad connection on a solar array. Sometimes people have issues with RCDs, which I'll go into completely, because RCDs, residual current devices, tripping, are a completely different thing. And yes, there are issues, and depending on who wiring, and especially see some terrible, some people with wiring the neutrals to the earth, which I know, I get it, it happens a lot. And then you're trying to run it through an RCD, and an RCD needs to see what goes in, what comes out. And if your neutrals then diverted back to the ground, the RCD will trip. So yes, which we'll cover some of that. But so today was basically just trying to cover sort of basics and why our inverter is nice. And quite honestly, it is. We have an amazing piece of kit. We've been working on this. I always call it work in progress, because we always try and make it better and better. And why Sunsynk? Sunsynk, our operating system is different. We have a different operating system. And we, quite frankly, I think we have the best operating system. We have a really nice operating system. Things occasionally, things happen, or external things happen, or lightning strikes happen. And it's also important to got some decent protection equipment using on your solar panels, fuses, lightning arresters, because if you're going to get a lightning bolt hit a panel or close by a panel, then it will blow. It will blow the panel. It will blow the inverter. And our inverter is a strong piece of kit. It's really strong, but lightning is stronger. So you need to make sure that you've got that. So anyway, that's basically what I'm trying to do today. I'm going to do some more information. So has anybody got any questions? Anybody want to ask me anything? Nope. Okay, well, if you've got any questions, feel free to ask. I apologize once again if I don't always reply on time, but I try to. I'm going to do I'll do some more in-depth courses. So today was just a very much an entry course. I'm going to do some other things, which I'm going to talk about wind turbines and using wind turbines. Yeah, I got a question. Yes, sure. You can, if you want to ask a question, just come up onto the forum.
Okay, I just want to ask one question. We've covered the basics of the inverter now, but you can also parallel these inverters. Are you going to cover that in a later stage? Or?
Yes, yeah. I'm going to do that because there's two ways of paralleling. One is on 3-phase and then single phase. There is a video on YouTube which I did showing the 6 inverters in parallel on a 3-phase configuration and some of the problems that you incur. But I'm going to do that another because it's the paralleling. I need to explain everything and go through it as a complete topic. So I will do the paralleling. I'll do that probably next week. And if other topics, because there's lots of other topics I need to cover, because the inverter does so many things. Because you can use it for load shedding, controlling a generator, controlling wind turbine. It does everything, and we try to think of everything when we put into the firmware, into the operating system. So yeah, and they parallel very nicely.
Okay, what also on the manuals is if you do paralleling and you put a generator, then you can't use the generator input, but we'll cover that later.
Yeah, you can.
The reverse current.
You can put generator onto. We can cut a specific question. You can put a generator on the gen input. You also just 1 point. If you talk about generators, how the unit operates, and I'll just go because it's okay. It's good to actually talk about these things. I won't go into massive depth, but let me just get the slide with the. I can show you something. Right. So this is on the. I've just changed the thing. So right. So here, this is the generator input, and so basically what you see. One thing to bear in mind, it will perform differently if you connect to the gen port as opposed to the grid port, as the grid. If you connect a generator to the grid, when the generator starts, the generator has to do one of two things. It has to charge the battery and supply the load. So if your generator is, if your load is an 8 kilowatt load, and you're going to have a 6 kVA generator, it's going to connect and the generator will do and die. It can't do it. And the inverter will shut down because the frequency will shut down and it will close down. You have to be able to supply the load. There are ways around it, which I can explain using multiple inverters. But if you just a simple single inverter or a 3-phase inverter, the generator must be big enough. Now, it doesn't just have to supply the load, it has to charge the battery because the inverter component will reverse. So once you put the generator, the inverter is up running in one direction, it's discharging from the battery. Now the generator is going to charge the battery, the inverter reverses. And so the generator has to power the charge the battery. And the battery could be charging at 160 amps. So the battery could be charging at 8 kilowatt and your load could be 8 kilowatt, 16 kilowatt. It's a 16 kVA big old generator. And it has to be powerful enough. It's not going to drop because when a generator, I've experienced this, I've seen it happen. And when the generator connects, you suddenly get a slight slowing down the generator. Your frequency goes out. and you're not running at 50 hertz because the generator connects, and suddenly the generator goes right down to 40 hertz, goes, it comes up, the regulator comes up on the generator. Rubbish generators and not powerful enough will cause that problem, and the inverter will trip out, and you'll try and do it again and again and again, and it won't work. It won't work. It will just go off and on, off and on. We did do a change. So if you connect on the gen port on the generator, and providing that generator is going to provide the whole load, if you're on a 3-phase load, it might be a big old load, the battery will jump the charge. It stages the charge. So what it does is, if you go on the grid side and it connects the back, it will instantly bump, it'll go on, and the batteries will start charging. If it goes on the gen port, it uses that. We put a staged charge, so it gives the generator a fighting chance. So if your load is fairly low, rather than suddenly hitting it trying to charge the batteries at maximum, it just stages it, but slowly increases the power to the battery charger circuit, because it's just trying to help the generator, because otherwise if the generator slows down too much, the frequency goes out and then the thing shuts down, and you're just going to cycle and never work. I don't know if that answers some questions.
Yes, it did. And then second question I've got. What is the recommended maximum distance from the inverter to your PV board?
Okay. So on the inverter, which is the on the CT coil, we say 20 meters. I know I've seen it work up to 30-40 meters. It depends on how much interference. We use a twisted cable because it's the ground going around. So use a twisted cable is best. 20 meters, no problem. We say, I think on the manual says 10 meters, but 20 meters, no problem. I've seen it done where there's no interference, longer, 25, 30, 35 meters I've seen. If the coil is going to go alongside lots of other cables and there's interference, then it's going to be much shorter. It will start giving problems. And then you're going to get all sorts of issues going on. So try to keep 20 meters or less. One of the things we're looking to develop is a wireless CT coil. So this is one of our developments is for our inverters, is to have a wireless CT. So which I think it will be a great opportunity. It means you can fit the inverter anywhere, absolutely anywhere, and the CT coil could be fitted. Could be communicating. So it'll make life much easier. Even for me, we've got a showroom here, and I want to put the mains coming into the building. It's miles away, so I can't even run a CT coil. It's too far away. So I just have to. We've got local setup here, but if I want to actually feed this back into the building, then it's a big problem. So we're looking at wireless CT coil. You can't use a conventional wireless CT coil. So normal wireless CT coils are no good because the speed. So our CT coil is going to work very fast and send information very quickly. So, but it's something we're looking at now. So generally, there are sorts of battery-operated wireless CT coils that people are using for power management, but they won't work because the speed has to be very fast reaction. But otherwise, it'll give somebody give problems, especially, for example, on prepaid meters. But this is a future development. The answer is, ideally 20 meters maximum. Sometimes if you're getting a very quiet like noise on the mains, or then you may get further. So okay, any other questions?
Keith, hi, Toby here. Thank you for your presentation. Very informative. Keith, I'm battling. I've got 3 Sunsynk 8 kilowatt inverters, a master A, B, and C, and each one feeds a phase. Now, we've checked phase A to the grid, to the first phase of the grid, the second, the third phase. My only problem is my BMS on inverter B and C doesn't communicate with inverter A. Inverter A is I can see all the information, but the BMS on B and C is all those zeros. What am I doing wrong?
Right. Have you? Okay. So if you're on parallel system, which is Modbus 1, the first one, if you've done a 3-phase, you know the class is 3 masters. The first one is the master overall. The battery can only communicate with one inverter, which is Modbus 8, which is the very first one. So yes. The first one, Modbus 8, the first one, Modbus 1, phase A is the number 1. It can only your battery. So your battery array, is it all communicating with the first inverter?
Yes. Yeah, the CAN is connected from my master battery to the CAN of my inverter A.
Right. And have you got any? And how is the battery connected?
Sorry. Okay, sorry. Just repeat that question.
So your batteries. Have you connected batteries? How have you configured the batteries? So basically, the inverter can only communicate with only one inverter can communicate with the battery array.
Okay, so the batteries on the master battery, it's communicating via the CAN to the inverter A. The other two batteries are all connected in parallel.
To the same inverter.
I've got 6 batteries. They're all connected to each other.
Yeah. Okay. And you've only used one CAN.
Correct.
Right. Okay. So if so basically, so the master inverter shows the other one should mimic. So you don't have any. There should be no communication cable off the other inverters to the batteries.
But how is the other B and C inverters going to read?
They read from the master. They read from the parallel cable. You don't need a cable. You don't have any communication cable on the other two inverters. They will all follow connection. So when you do the paralleling, they will update themselves. They will all update. So if there's an issue, reset them all. Don't have any cable. You must not have cables on the other two inverters to the batteries. Only the master inverter is the one that communicates. The others don't have battery communication cable.
Okay, then the other question is, do they need to be set up in parallel? If you've got one inverter per phase.
Yes, you've got batteries, absolutely. And the batteries must be common. So you must have a common bus for the batteries. So the 3 inverters must be on a common bus, and they must be in parallel. If you haven't got if there's a problem with the communication, you'll get a parallel fault because it will shut down. So there must be. There's actually, if you go on the YouTube, there's a video where I'm showing it. But there's lots of things going on there. So first of all, you've got to make sure that you've got your first set. Your batteries are communicating to the master, which is all good. Then you've got to make sure that your phase rotation. So I'll go through this on another video, but there's a video going on about which your phase rotation is correct. So it's going to go from master next, master next in that rotation. If the phase rotation is out of order, then you're going to get a fault, and it's going to drop as a communication fault. So you must make sure your batteries are only communicating on the master only. Your parallel cables are connected correctly. You've got the correct phase rotation. Have a look at the video. There's about a 15-minute video on YouTube, which I did, and showing you how to set it up. And I go into quite a detail. So it's quite a good one to look at.
So just the last question, the phase rotation on the inverters compared to the grid's phase rotation, is that the same?
Has to be the same, correct.
Because we double check the power from the inverter to the first, call it the red phase, B to this yellow phase, and C to the blue phase, and all those powers is connected 100% correctly.
Right. So you sound like you need to look at your battery. So it sounds like you've got a battery thing. You've got your battery set up wrong, because your communication shouldn't be. You should have no battery communication cables for the other two inverters. You only use one.
There is no battery communication, nothing whatsoever. But so I haven't put the paralleling on. Is it the paralleling causing?
Oh God! If you don't, you've got to have it paralleling. Otherwise, you're going to get all sorts of weird things. It won't be 3-phase. You'll have voltages. If you try to put a 3-phase configuration without the paralleling, then you're going to get massive. You're not going to get phase rotation. You're on grid. You're going to have huge problems.
Okay.
You're going to blow it up.
I'm not the electrician, but nevertheless, we'll sort it out. Thank you so much for your.
No. Oh God's sake! No, you got parallel. This is 3-phase. This is 3-phase, 380, 440 volts, depending on where you are. Is dangerous stuff. Absolutely. They've got to have. So no, they've got to have paralleling. It's got to be done correctly. There is a commissioning process, and the video I did, I tried to explain a little bit. You know, I'm an electrical engineer by trade, and I started off in life wiring these stuff in the factories and in 3-phase. That's what I started life doing. So yeah, you know, I've seen co-workers being caught fingers across the 3-phase supply and end up in hospital. It's much worse than 240 or 220 volt. It lands you in hospital. Right. So you're really careful, and the DC stuff off the solar panels, that'll throw you off a roof. Okay. Anything else? No. Okay, we're going to end now. So it's just an hour training. So I hope it's been useful. I'll put the video on the site. And thank you for everybody for joining us. So I'll put the video up if anyone wants to relook what we've done, the whole thing. So thank you very much. Thank you.